guys, we are back with the introduction to deep learning series by IST. Today we will be going ahead with hyperparameters. Let us look at the difference between model parameters and hyperparameters. Model parameters. Model parameters are internal to the network. For example, neuron weights, biases. These are estimated or learned automatically from training examples. These parameters are also used to make predictions. Hyperparameters. Hyperparameters are external parameters set by the operator of the neural network. For example, selecting which activation function to use or the batch size used in the training. Hyperparameters have a huge impact on the accuracy of a neural network. There may be different optimal values for different values, and it is not trivial to discover those values. Hyperparameters are the variables which determine the network structure. Example, number of hidden units, and the variables which determine how the network is trained. Example, learning rate. Hyperparameters are set before training. Example, that is, before optimizing the weights and biases. Here is the list of common hyperparameters. Let's have a look at each one of them. Number of hidden layers and hidden units. Adding more hidden layers of neurons generally improves accuracy to a certain limit, which can differ depending on the problem. One hidden layer is sufficient for majority of the problems. But if the test error is significantly large, just keep adding layers until the test error does not improve anymore. What about number of neurons? The optimum size of the number of hidden units is usually between the size of the input and the size of the output layers. In short, for most of the problems, one could probably get decent performance by setting the hidden layer configuration using just two rules. Number of hidden layer equals 1, and the number of neurons in that layer is the mean of neurons in input and output layers. Activation functions. For hidden units, generally value activation function is the most popular. Sigmoid and tanh are used in the output layer while making binary predictions. Softmax is used in the output layer while making multi-class predictions. For output layers, if there are two mutually exclusive classes, then your output layer will have one node and a sigmoid activation function should be used. If there are more than two mutually exclusive classes, then your output layer will have one node per class and a softmax activation function should be used. If there are two or more mutually inclusive classes, then your output layer will have one node for each class and a sigmoid activation function must be used. Coming to weights initialization. It is necessary to set initial weights for first forward pass. Two basic options are there. To set weights to 0 or to randomize them. Perhaps the only property known with complete certainty is that the initial parameters need to break the symmetry between different units. If two hidden units with the same activation function are connected to the same inputs, then these units must have different initial parameters. If they have same initial parameters, then the deterministic learning algorithm applied to the deterministic cost and the model will constantly update both these units in the same way. Hence, if we initialize all initial weights and biases with 0, we will face this issue. Thus, random initialization of initial weights and biases is preferred. Neural network learning rate. The amount that the weights are updated during training is referred to as the step size or the learning rate. The learning rate is a configurable hyperparameter used in training of neural networks that has a small positive value, often in the range between 0 and 1. During training, the backpropagation of error estimates the amount of error for which the weights of the node in the network are responsible. Instead of updating these weights with the full amount, it is scaled by the learning rate. When the learning rate is too large, gradient descent can cause a drastic increase rather than decrease in training error. When the learning rate is too small, the training is not only slower but may become permanently stuck with a high training error. Unfortunately, we cannot analytically calculate the optimal learning rate for a given model on a given dataset. Instead, a good learning rate must be discovered via trial and error. Deep learning epoch, iterations, and batch size. One epoch is when an entire dataset is passed forward and backward through the neural network only once. Total number of training examples present in a single batch is batch size. Iterations is the number of batches needed to complete one epoch. These parameters determine the rate at which samples are fed to the model for training. Since one epoch is too big to feed to the computer at once, we divide it in several smaller batches. If the epoch cannot be run all together due to the size of the sample, it is split into batches and the epoch is run in 2 or more iterations. That's it for hyperparameters. Thank you.